Right, let's get straight to it. Differentiating products and quotients? It is without a doubt one of the most notoriously misunderstood areas of the entire Cambridge IGCSE AdMath 0606 syllabus. Zero fluff today, guys. In this explainer, we're unpacking the exact examiner strategies that are going to instantly fix your methodology and secure those crucial grades.
So you really have to ask yourself, why do so many genuinely smart students lose marks on the product and quotient rules? Well, honestly, it's not because they can't do basic calculus. Not at all. It's because they fundamentally misunderstand what the examiner is actually looking for when the algebra gets heavy.
And look, here is why this matters so incredibly much. We are talking about high-value marks being thrown away purely due to flawed methodology. Failing to grasp the core conventions here, it can literally be the difference between grade boundaries. It's that serious.
Section 1. The Calculus Exam Trap. Flawed versus top-band answers.
Okay, let's dive into this. If you're just doing ordinary repetitive revision, you might be falling into a massive trap. Look at the stark contrast here on the screen. Take a mental second to spot the error. On the left, we've got a generic, flawed student answer. It's just a wall of algebra, right? Zero context. But then look at the right side. The top-band answer communicates clearly. It defines the terms, applies the rules systematically, and links right back to the context. This exact shift in presentation is what bumps you straight up the mark scheme.
Moving on to Section 2, Core Principles, the Examiner's Secret. Listen, if you want to think like the person actually grading your paper, you need to understand the theoretical architecture behind the exam itself. The absolute quickest win you can get right now is grasping these assessment objectives. Examiners are targeting distinct cognitive domains here: your baseline knowledge, your ability to apply that knowledge, and your analytical skills. When you evaluate whether an equation needs the product or quotient rule through these three specific lenses, you stop just doing math and you start engineering a perfect mark scheme response.
To hit those top-tier marks, examiners want to see precise definitions and clear causal relationships. A massive takeaway from the principal examiner reports is that candidates who reference cross-topic connections, like linking a derivative back to coordinate geometry or kinematics, they achieve significantly higher marks. It's like a giant puzzle for them.
Well, that brings us to a really critical question. What is the classic context trap that ruins even the most perfect equations? In just a moment, I'm going to show you the exact examiner clue that changes your answer completely. But first, we need to build the framework that makes that clue incredibly obvious to spot.
Section 3. The Method Mark Strategy. Process over final answer.
This method mark strategy right here is all about prioritizing the process over the final answer, which honestly should reduce a lot of your exam anxiety. Examiners actually award marks for your process, even if your final number is slightly off. So, you've got to follow these 5 strict procedural steps. First, deconstruct the question. Second, extract the relevant data. So, identify your u and v functions, those distinct parts of your equation being multiplied or divided. Third, select the analytical framework. Like actively state if you are using the product or quotient rule. Fourth, execute with clear notation. And fifth, present it all with correct terminology. And this brilliantly illustrates exactly how you should tackle these exam questions.
Because trust me, the presentation of your information matters just as much as the math itself. You absolutely must use proper headings, correct calculus terminology, appropriate formats, and clear annotation. For instance, clearly annotating your derivatives before you plug them into the quotient formula, that is exactly how you lock in every single method mark available. These strict conventions are your best friend here for sure.
Section 4. Escalating the stakes. Critical analysis and problem solving.
Now, this is where we escalate things and move from basic application to higher-order assessment objectives. When you're evaluating a complex function, you need this deconstruct, solve, evaluate framework. First, identify the given information. Second, break it into logical steps. Look at the quotient rule formula right there in the center. You have to clearly derive your individual u and v parts before combining them into that larger structure. Third, solve systematically. Fourth, check for reasonableness. Ask yourself, does your derivative actually make sense for a gradient in this specific context? And fifth, make justified recommendations based on your evidence.
All right, here's a quick comparative analysis challenge for you. Can you spot the missing similarities and differences here? Take a mental pause and predict the outcome. When you're comparing two different approaches to a derivative, you must use comparative connectives and support each point with evidence. If you just list facts without drawing conclusions about their relative importance, you are dropping those higher-order marks. No way around it.
Section 5. Principal Examiner Warnings. The top 3 mistakes.
Okay, to close that open loop from earlier, here are the exact traps that ruin equations pulled straight from the Cambridge Principal Examiner reports. Number 1, using the wrong approach entirely for the given context. Number 2, completely forgetting to check your format and presentation, which means dropping those easy method marks we just talked about. And number 3, providing answers that are entirely not specific to the context given in the question.
This last point is so absolutely critical that I want to read you this exact examiner alert directly from our source material. Quote, "The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario," end quote. So if you are differentiating a volume function to find a rate of change, your final answer has to relate back to that volume in time, not just basic x and y variables.
Section 6, Final Recap, Securing the Grade.
So the crucial point is that mastering these rules isn't just about rote memorization. It's about executing a highly precise strategy under pressure. Let's bring this all together with a lightning-fast summary of your 3 vital takeaways. First, deploy the method mark strategy. Remember, process is always greater than just the final answer. Second, demonstrate cross-topic integration whenever possible. And third, always ensure context-specific presentation. Memorize this visual story, and you'll be thinking exactly like an examiner.
But here is the reality check, guys. You have the high-mark exam strategy now, and you know how to avoid the classic examiner traps. But what if your exam is only 7 days away? Having a strategy is great, but you need a map to actually execute it effectively under a strict deadline. That is exactly why you need a concrete step-by-step action plan for your final week. This is your mandatory next step, the Mathematics Additional 606 Last 7 Days Revision Map. Subscribe to our YouTube channel, Ace the Exams at Ace the Exams IGCS, to excel in your Cambridge examinations.
The clock is ticking, and those grade boundaries aren't waiting for anyone. Are you ready to map your last 7 days and completely ace the 0606? Don't leave your final grade to chance. Take action now. Apply this framework, and let's go secure those top band marks.